Hello all, in the series of covering SAT topics, this is our 13th video where we will discuss about rational functions and complex numbers. So first of all, what rational function is? So any function in which we will be having polynomials in numerator and denominator are called as rational functions. That means basically these types of functions will be in fractions. For example, we can take fx is equal to x square plus 5x minus 6 divided by 2x minus 3. So this is a rational function. Now we always have to remember that the denominator of a rational function cannot be 0. Denominator of a rational function can't be 0, because if it will become 0, then the function will become undefined. That's why denominator cannot be 0. Next, how to simplify these type of rational functions? Simplifying rational functions. So to simplify rational functions, what we can do, we will take out common factor from numerator and denominator and cancel them out. Now, how we can see this thing? Let's see through an example. For example, taking this question, it says that when x to the power minus 1 is divided by x minus 1, then the quotient is. So basically what it is saying, x to the power minus 1 divided by x minus 1. So how we can solve this? This is equal to, using the rule of exponent, we know that a to the power negative n is equal to 1 over a to the power n. So using that, we can say x to the power negative 1 is 1 over x minus 1 divided by x minus 1. We can make the denominator common for these two fractions. So then how will we be making denominator common? We can multiply the second fraction by x over x. So we will be getting 1 over x minus x over x divided by x minus 1. So that is equal to, if you see, we can write 1 minus x over x. That is the numerator, and denominator is x minus 1. That means this can be written as 1 minus x over x times of x minus 1. From the numerator, we can take negative 1 common. So we will be getting negative 1 times of, that means we can simply write negative times of x minus 1 divided by x minus 1. So here x minus 1 gets cancelled out and x is there in multiplication in the denominator. So we will be getting negative 1 over x as the answer. So if we see the options, it's option number B. So these type of questions we can get. So here there was no any equation. This was just an expression and we had to simplify that. Now it can be possible that we have to solve the equation. So solving fractional or rational equations. So what we can do here? Suppose we have this question and we need to find the value of n square. So what we will be doing here, as you can see, we are having 2 times of n minus 1 over 3 minus 3 times of n plus 1 over 4 equal to n plus 3 over 2. So to solve this type of fractional equation where it is not a rational equation of that type, we will have to face that much of difficulty. So we are having 3, 4, 2 and common multiple of 3, 4 and 2 is 12. So we can multiply both the sides by 12. So we'll be getting 12 times of 2 times of n minus 1 divided by 3 minus 12 times of 3 times of n plus 1 divided by 4 is equal to 12 times of n plus 3 divided by 2. So 12 will be cancelled out in 4 times, then 3 times and then 6 times. So we will be getting 4 times, that means 4 times 2, 8 times of n minus 1 minus 3 times 3, 9 times of n plus 1 is equal to 6 times of n plus 3. So what we are getting from here, we can write minus 9n minus 9 is equal to 6n plus 18. So from here we can say 8n minus 9n, that is negative n, negative 8, negative 9. So we'll be getting negative 17 equal to 6n plus 18. So from here we can say we can add n to both the sides and we can subtract 18 from both the sides. So we can write negative 17, negative 18 is equal to 6n and plus n. So we are getting negative 35 is equal to 7n. So we can divide both the sides by 7 and we will be getting n equal to negative 35 over 7, that is negative 5. Now n is negative 5, but we need to find n square. So n square will be negative 5 square, which is basically positive 25. So this is how we can solve the rational equations or fractional equations, and we can simplify rational or fractional equations. Now even it is possible that in the numerator and denominator both are having different polynomial functions, like suppose quadratic is in the denominator, cubic is in the numerator. If there is any common factor between those two functions, then we will cancel them out and the simplified form will be the answer. If they cannot be cancelled out, then we can simply say that it cannot be simplified. So this is all about rational functions. Now coming to complex numbers. So in complex numbers, basically what is complex numbers? When an imaginary number is combined with real numbers, then the number formed is called as the complex number. That means basically combination of real number and imaginary number is complex numbers. But how will we getting imaginary number? What is the imaginary number? So for getting an imaginary number, we always have to remember that inside any even radical functions, there cannot be any negative numbers in general. But if there is any negative numbers inside even radicals, then we can say that that is an imaginary number. For example, the square root of negative 5, the square root of negative 7, fourth root of negative 8, sixth root of negative 48. These are imaginary numbers. Now if these are imaginary numbers, but if you will take, see, these are imaginary numbers, but for example you are taking cube root of negative 8, then that is not an imaginary number because this is odd radical number. And odd radical number in negative number is defined. So basically here cube root of negative 8 will simply become negative 2 because we can multiply negative 2 3 times and we can get negative 8. But any negative numbers after multiplying even number of times, we cannot get any even number. So that's why that is imaginary number, but this is real number. Now for the base of imaginary number, we know that for the base of the imaginary number, square root of negative 1 is defined. That is called as I. So on the basis of this only, we define the other numbers. Like the square root of negative 5 I had written, so that can be written as root 5i. Because a square root of negative 5 can be written as square root of 5 times of square root of minus 1. So that is square root of I. Suppose we are having square root of minus 16, then that can be written as square root of 16 is 4 and square root of negative 1 is I. So that will become I. Now coming to higher powers of I. So in this case, suppose we are having I, then we know that that is square root of negative 1. Then I square, that means we have to square this. So we'll be getting just negative 1. I cube means negative 1 multiplied by I. So we will be getting just negative I. Then I to the power 4, that will be equal to square of negative 1, that is 1. Again, if we do I to the power 5, it will start repeating from here. So we can write square root of -1 either, or we can write just I. Then I to the power 6 will become -1. I to the power 7 is I to the power 8 is 1. So basically in general form we can say I to the power 4n plus 1, that is I to the power, because it is repeating after every 4 terms. So I to the power 4n plus 2, that is I to the power 4n plus 3, that is here it's -1, and here it's -I. And I to the power 4n, we will not say 4n plus 4, because it's either 4n or 4n plus 4, it's the same thing. So that is 1. This is how we can define higher powers of I. Now, properties of imaginary numbers. So how we can say the properties of imaginary numbers? So first, I can be treated as a monomial in any arithmetic operation. Then, while adding or subtracting two complex numbers of the form a plus bi, where a is the real part and b is the imaginary part. The real parts are combined together, whereas imaginary parts are combined together. For example, we are having z1 is equal to a plus ib, z2 is equal to c plus id. Then we can write z1 plus z2 will be equal to, we can combine the imaginary parts, so a plus c plus b plus d times of I. Same we can do with subtraction. Next, multiplication. So we can use box method or FOIL method to multiply, and will simplify higher powers of I at last. For example, suppose we have a question to multiply 3 plus 4i times of 2 minus 3i. Then what we can do here, as we were doing in polynomials, we will multiply here also, as we can treat I as a monomial. So that means basically we are having a polynomial having variable I. So 3 times of 2, 6. 3 times of -3i, so -9i. 4i times of plus 8i. Then 4i times of -3i, so -12i square. So we will be getting 6. Then -9i plus 8i, so we will be getting -i minus 12, and I square can be written as -1. So we are getting 6 minus I plus 12, which can be simplified as 18 minus I. Next is division. So while dividing by any complex numbers, we rationalize the denominator to make sure that there is no complex number in the denominator. So for example, what we can do here, suppose we are having a question 5 minus 3i divided by, we can take 3 minus 2i. Then what we will be doing here, in rationalization, we will do the same thing here. So we are having 5 minus 3i divided by 3 minus 2i. We will multiply this by 3 plus 2i divided by 3 plus 2i. Then what we can get, 5 minus 3i times of 3 plus 2i. We will simply use FOIL method. So 5 times of 3, 15. 5 times of plus 2i, so plus 10i. Negative 3i times of 3, so negative 9i. Negative 3i times of 2i, so negative 6i square, divided by, as you can see, a minus b times of a plus b, and we know that that is a square minus b square. So we can write 3 square minus 2i square. So this can be written as 15 plus I and minus 6 times of -1, because I square is -1, divided by 3 times of 3, 9, and minus, here we will be getting 2i square. So I square is -1 and 2 square is 4. So we will be getting -4 here. So this can be written as 15 plus 6, that is 21 plus I divided by 13. We can either leave in this form or we can separate the imaginary and real part. So we can write this as 21 over 13 plus 1 over 13 I. So that is how we can simplify while dividing. Then next is conjugates. So basically what we multiplied there, that means we were having 3 minus 2i and we multiplied by 3 plus 2i. So that is known as conjugates. So conjugate of z is equal to a plus ib. Here conjugate is represented by z bar. So conjugate of z is equal to a plus ib is given by z bar, and that is equal to a minus ib. Now let's take a word problem from complex numbers. So suppose this is the question where it says in an electrical circuit the voltage E in volts, the current I in amperes, and the opposition to the flow of current called impedance Z in ohms are related by the equation E equal to Iz. What is the impedance in ohms of an electrical circuit that has a current of 3 plus I amperes and a voltage of negative 7 plus I volts? So as we know that E is equal to Iz, that means, can we say that, see here what is given, current is given, that means I is given 3 plus I, and then voltage is given, that means E is given, that is equal to negative 7 plus I, and we need to find the impedance. So we can say Z is equal to E over I. So that can be written as negative 7 plus I over 3 plus I. Now we can multiply this by its conjugate. So we'll be getting conjugate of denominator. So 3 minus I divided by 3 minus I. So numerator becomes negative 7 times of 3, that is negative 21. Negative 7 times of negative I, so that is plus 7i. I times of 3, so plus 3i. And then I times of negative I, so minus I square, divided by 3 square minus I square. So what we will be getting from here? Negative 21, and this will become plus 1 because I square is negative 1 and one negative sign is already there. So what we will be getting here? Negative 20 plus 10i divided by, here we will be getting 9, and this will become again plus 1. So that is equal to negative 20 plus 10i divided by 10. So we are getting negative 2 plus I, or simplifying. That means we can say this is as I, negative 2 plus I, that means option A is the answer. So that's all on this topic. We will meet again in the next video of this series. Thank you.